from the last class. Okay, now we have started with our regression analysis, and I explained you what is linear regression, how to identify the straight line, and what is the best fit line, which helps us to identify the relationship or estimate the relationship between the independent and dependent columns. And the equation of this straight line is y is equals to mx plus c, and you know, uh, that is m is nothing but the slope, okay, and c is y-intercept. Now in this, if you take it, the point at which the line will cross the y-axis, that is called as y-intercept, and slope is nothing but the angle at which the line is inclining, is called as slope. And the equation of this slope is y is y2 minus y1 divided by x2 minus x1 when you are dealing with the two points. Okay, but when it is a multiple points over here like this, then the equation gets slightly changed. That will be xi minus x bar into yi minus y bar divided by xi minus x bar whole square and summation. This we have done it over here, taking some dummy data. X value is 1, 2, 3, 4, 5. Y value is 3, 4, 2, 4, 5, something like this. And xi minus x bar, x bar is nothing but mean, and y bar is mean. X bar is 3, y bar is 3.6. Here, xi minus x bar, that is minus 2, minus 1, 0, 1, and 2. When it comes to yi minus y bar, that is this value, you are going to subtract it from the 3.6. That is 0 minus 0.6 minus 0.4 minus 1.6, 0.4, 1.4. Okay. Now, when you multiply these two, you're getting 1.2 minus 0.4, 0, 0.4, 2.8. You are adding them to get the total. That is the summation, the first part. And here, in this case, you will be getting the xi minus x bar whole square, that is the denominator part. So we got it 4 by 10, that is 0.4, we got it, and C we got it 2.9. Now, using these values in the equation, I was able to predict these things. Till here, it was okay. Okay, this was good enough till here. Now the question comes is, okay, what is the question will be like, well, how to know that this is correct or how to know that these are correct or wrong? Like they are right or wrong, these things, whatever is being predicted. Is there any error? Yes, or this equation is correct, or is there any mistake in this? Definitely, it will not be 100% perfect. There will be some slight error will be there. Now, how to identify that errors? How to find the errors? So, these techniques, once again, okay, this finding of the error is called as error matrix. They are called as error matrix. I'm going to find it out. I'll put it on over here. error matrix. Okay. Now there are multiple errors will be there. Multiple error matrices are there. We are going to do that one today. Okay. Now the question is, this is the data given. Okay. Now how to find out whether there is an error or not, whether this equation is correct or not. In a simple way, my equation was y is equals to y is equals to, I will give it as mx plus c, but y is equals to m is 0.4 into x plus 2.4. This is an equation. Is this equation is correct or not? How to know that? Simple, guys. This is the one which is given to us. Okay. This is the one which is given to us. Here. And this is my x. X is my independent value. Always remember, stick to the basics. Okay. So and y is a dependent value. Okay. Y is a dependent. This is given to us. This is very well given to us. Based on the x, they got the y. Right? This is given to us. We are not going to do anything over here. It's already given. Now, what I'll do it is, if you want to check it out, your equation y is equals to 0.4x plus 2.4 is correct. Just put this x value over here. Then your y value should be this. If it is 100% correct. If it is more or less, there is an error. Okay, simple. So now I'm going to take it over here. I'll just take it a bit up. Okay. Now first I will do it like this. This is my y. Now this I will take it as y. This one I will take it as y predict. Now y predict, usually we will indicate it with y hat. Y predict, we will indicate it with y hat. So what we are going to do it over here is, I will give these values into this and I will check it out what will be the y value which is predicted by this one. This is the actual y, original y value. This one is predicted y value. Y value which we indicated as a cap. Okay. Original y value and predicted y value. Okay. Now, what we are going to do it is, we are going to give it. Now let's do it one after the other. I'll take it as 0.4 into x plus 2.4. Now my x value is first 1. Okay. Now I'm supposed to get it what? 3. What I got it? 2.8. So here I'm having 2.8. Now let's go with the 2 over here. I'm going to make it 2. With this, I will put down over here. Here I will give it as 2. Now here 3.2. Actually, I was supposed to get 4. Here I got 3.2. That is, there is an error of 0.8. Right. Now the third scenario. Take it. This one. I will give it as here 3.6. Actually, it should be 2, but it went over that. That is 3.6. I got it. Again, here there is error. Okay. Let's do the next one. That is 4. I got it 4. 4 and 4. Here I was expecting the 4 and I got the 4. So there is no error over here. Okay. Now the next one is, I will keep it as 5. 4.4. Like this. Okay. So 3, 4, 2, 4, 5. That is, I got it 2.8. Here there is an error. And here there is an error. Here there is the fourth one is not having any error. Here 4, here 4, and here there is an error. Now the question is how to find out the error. Okay, I'll put it on. Simple. If I ask you now, please remember this one. Okay. Now, if I ask what is the error? See, this is the actual value. This is the predicted value. Actual value is indicated with y over here. Okay, actual value is indicated with y. Predicted value is indicated with the y hat. So what you will get it, y minus y hat is nothing but the error. Y minus y hat. I will give it over here above this itself, like this. Y hat is the error of individual values. Again, don't get confused. It is the error of individual values. Y minus y hat. Okay. Now let's calculate the error. Okay. First, 3 minus 2.8 is 0.2. Right? This is the error we got it. Now, next one is here 4 minus 3.2. Then we will be having 0.8. 8. Next one, 2 minus 3.6, that is minus 1.6. Next one is 4 and 4, 0. Next one is here 0.6. This is the errors. Individual value errors. Individual value. Again, take it over here. That is individual values. Errors. Calculating the error for individual values. How you calculated the error? That is y minus y hat. Y hat. This is the way we will do it. Okay. Now, I want to get the total error, guys. Total error means add them. Simple. That is, total error is total error is you have to add it. That is called as summation of y minus y hat. Can I say that? Yes. Because we are going to add it, when you add them, we will call it as summation. This is our individual value error. When I want to calculate the total error, I will call it as summation. Okay, summation of cap. Here this is cap. It's looking a bit different. So I'm giving it as a cap like this. Perfect. Now understand this terminology, guys, please. This total error we usually represent as R. R, capital R. Now, what is this R indicates? R indicates R. What is R, right? R indicates residual. We call it as residual. Okay, that's fine. Now, residual, we got it. Now, residual is the formula is this one only. Total error is R. Residual R formula is R is equals to, that is nothing but summation of y minus y hat. Summation of y minus y hat. This one. Now let's do the residual total error. Let me add them. If you want to add them, let's do it. First is 0.8, so 0.2 is the error. We got it. And then plus 0.8. Now where I am getting this? This one. 0.2, 0.80 and 0.6 minus 1.6. So here I will give it as plus brackets minus 1.6 plus 0 plus like 0.6 like this. So I'm adding it. I'm very anxious to see that what is the total error. Now when you see the total error, I'm getting 0. That means what this means is there is no error at all. There is no error in this. This is perfect. That is 3 when I'm giving it over. Sorry, 1 when I'm getting 3. But here I have 2.8. And when I'm giving 2, I have to get 4. I have to get 4 if there's no error. But I got it 3.2. There is an error. And here 3 when I give it, I should get 2. I got 3.6. Again there is an error. There is an error. But here it is showing it as there is no error at all in your model. Now this is a problem. Why? See, there is error, but unfortunately we don't have this. It's showing us there is no error because of the sign. Because of the sign, it is neutralizing the value. Because we have the sign, so we are neutralizing the value. So I want to remove this sign problem from my calculation. So how you'll do it? Whenever you want to neutralize the sign, we will like to go with square. R square. Okay. R square is nothing but, that is, when you put it in the formula, when you update the formula, that is y minus y hat whole square. Y hat whole square. That is, we will do this square, 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 and we will do. Okay. We are going to perform the squaring over here. Okay, 1 second, guys. Just give me a second. Now, let's calculate the square over here. Simple. Here, when I do it something like this, I will do it. Or let me write it down. That would be much better. Let me type it so that I can do it a direct calculation. This will be like 0.2 into 0.2. Okay, plus I'll give it as 0.8 into 0.8. Okay, plus we will give it as, sorry, 1 minus 1 minus 1.6 into minus 1.6. Okay, plus next one, 0 into 0 is 0. That is 0.6 into 0.6. Now I got it 3.6. Now we remove the sign. Definitely we remove the sign. This we got it 0.4 and 0.16 and 0. This is 3.2 kind of stuff. You will be getting it. When you add it completely, you will be getting 3.6. That's fine. Okay. Now our R square is nothing but 3.6. What is this actually? This is a total error. Okay, this is a total error. Now, one thing you should understand over here, when we are, this is called as R square error detection mechanism, which is also called as we also call as error matrix. Okay, that is R square. We call it as R square. That is error matrix. This is R square, but it is represented as R square. R square is a error detection mechanism which is called as error matrix, and this formula is this. Remember this: summation of y minus y hat whole square. Okay, this is a very popularly asked interview question. What is R square? Is summation of y minus y hat whole square. Okay, why we have given the whole square? To neutralize the sign and to get the error. Now, when you observe this error is nothing but, total error. After squaring, this is the total error we got it. Now, what I want to do it is, I want to distribute this error equally to all the data points. How many data points we are having? 5 data points over here. These errors, I want to distribute it to the 5 data points. How you'll do that? Simple. You have R square. I'm writing it R square only. R square, and your value is 3.6. Now divide it by 5. Divide it by 5. Now you will get it as 0.72. So each data point we are giving an error of 0.72. This all. This one is given as 0.72. 0.72. This is 0.72. This is 0.72. This is 0.7. But one thing you should understand, that is, this is the squared value. Actual error is 0.2. But we squared all of them, we added them, and we distributed to all of them. This is the squared value. Now, what we are doing is a small error, we are squaring it and showing it as a very big error. Now, like this, like I will give it as, suppose if there is a student is there, he is a student. his um his passing, he has to pass the exam. The passing score is 50. Now this gentleman, he got it 41. He got it 41. The passing square is 50. Now how much is lacking? 9. Of course, if you're getting doubt, I will write it in a reverse way. Here it is 50 minus 41. So there is 9. There is 9. Okay. The error is the mistakes what he has done is lacking 9 marks to pass it. Okay, he has done 9 marks. Now, or let's take it for out of 50 questions, he added only 41. He gave the correct answer for 41, and mistakes he has done it is 9. Let's take 50 questions. He has given 41 right answers. Mistakes is 9. Now, what you are doing is you are making it as 81. You are squaring it and if someone asks, instead of saying 9, you give it as 81 mistakes he has done it. So what you are doing? A small mistakes, you are doubling it, you are squaring it and showing it as very big mistake. Right? This is the problem over here. Okay? Right? So the same thing we are doing it over here. We were having a small error, 0.2, and one is 0.8. Then what we have done is we have squared it and we distributed, and that error is showing it so big, 0.72, 0.72. Okay. Now first thing is how you distributed that one? By dividing it by 5. This one we call it as mean. We calculated the mean. So now after applying the mean, this r square, we call it as r square is 3.6. We are applying the mean, so we call it as mean square error. Mean square error. This is also represented as MSE, mean square error. Got it? Now, next one is again, after applying the mean square error, I'm getting it as 0.72. But that effect of square is still there. That effect of square is still there over here. So I want to remove the square. How to remove the effect of the square? We will apply the square root. That's it. So I will apply the square root on this. Like this, we will apply the square root on 0.7. Now let me calculate it. I'll use a calculator. Zero 0.72. Apply the square. That is 0.84. Is it correct? I'm taking the things. Square. Yeah. This is square root. I'm applying 0.8. Now this value is coming down as 0.8. After applying 0.8.